Today I'll be talking about dismissal threats as a type of incentive, and I'll talk about why we might expect the threat of being fired to be particularly motivating for workers and why we'd want to run an experiment to answer questions about it. So the threat of being fired is widespread throughout the labor market. A recent poll taken during better economic times before COVID showed that about half of employed Americans experience significant anxiety over losing their job. Now, few jobs are entirely devoid of firing threats, but in practice, the intensity of the threat of being fired varies a lot. You could think of unionized jobs or jobs in the public sector, or maybe places with strong employment protection laws. In those cases, your productivity is not very closely linked to your chance of being fired. And contrast that with jobs like a Fortune 500 CEO of a big publicly traded company, where their chance of being fired kind of closely tracks their stock price, or maybe assistant professors at, say, Harvard, where maybe you have a 1 in 10 chance of keeping your job and getting tenure. There, your productivity is very intricately linked to your chance of losing your job or keeping it. Of course, dismissal threats are only one part of a broad package of job traits, things like compensation and bonuses and location and so on, and workers are self-selecting into these jobs. It's not cleanly imposed. And these are some reasons that we might want to take questions about types of incentives to the lab. So I'm going to have two primary research questions. The first one is about the existence of dismissal threats. So how motivating are dismissal threats as a type of incentive compared to a simpler incentive like piece rates, where you're just getting paid per unit of output? In the lab, I'm going to be able to explicitly quantify the monetary value of output under dismissal threats, right? So I know how much it's worth to complete one real effort task under dismissal threats in the lab, whereas in the field, it's difficult to explicitly contract on dismissal threats. It's usually not in a labor contract. Given that I'm doing this in the lab and that behavioral motivators are an important part of why dismissal threats are motivating, I'm going to be intentionally including some of those behavioral motivators. I'll have a loss framing where it's phrased as sort of losing your job and missing out on income. I'm also going to have some sort of social and self-image relevant signals where there are these public announcements of who's been fired. And I think there'll also be some feelings of exclusion or jealousy of people who are fired, of the people who are continuing to work and earn money. The second question is about the intensity of dismissal threats. So given that you're going to use this type of incentive, what happens when you intensify it? If you think about the relationship between your productivity and the chance of being fired, you could think about sort of steepening that relationship so that your productivity matters more. Of course, with a stronger incentive, we expect higher output. That's just a straightforward incentive effect. That's people responding to incentives. But there's also a more subtle selection effect where more productive workers will select into jobs with higher pay and stronger dismissal threats. My design will be able to decompose these two effects and also analyze some heterogeneity in the incentive effect. So in other words, on what sorts of workers do intense dismissal threats work the best at making them more productive? So I'll quickly go over what's been done before in kind of three phases here. So experimental work on incentives in general is the first bullet point here. Experimental work on motivating workers has largely focused on other types of incentives. And of course, this is important work. It's on things like piece rates, teams, and tournaments, and so on. They also use either guaranteed selection into an incentive scheme or just totally random assignment to an incentive scheme. I'm going to have a mechanism that incrementally improves on this that I'll talk about during my design section. Some recent work has looked at dismissal threats as a type of incentive, but it's usually used human bosses. And while that's an important social element of the threat of being fired, you sort of lose control over the monetary benefit of output. So you can't measure and control it as well as you can without relying on another human subject. And finally, there's a lot of important applied work where they will look for plausibly exogenous policies or changes in firm management and so on. And they'll find things like lower absences after an exogenous shock that lowers the chance of being fired, or effects of employment protection laws on employment levels of protected groups, and so on. But something that this applied work cannot do is measure the preferences of workers over types of incentives or incentive schemes, and then run them through different types and levels of incentives, and many of them. Okay, so that's kind of what I'll be doing. So, okay, so what do I actually do in the experiment? I'm gonna have subjects completing a real effort task for pay, and they're gonna go through a series of incentive schemes, basically. After a tutorial and an unpaid work period, they're gonna go through 2 piece rate work periods, one low piece rate and one high piece rate. So there's a 1 cent per task period and a 20 cents per task period. Then they'll go to dismissal preference elicitation, where I offer them 2 jobs and they pick between the 2 of them. They differ only in the fixed payment per period and in how strong the link is between productivity and the chance of being fired at the end of the period. Then they're going to go through 3 dismissal threat work periods where they're earning a fixed amount of money per period. If they're fired at the end of a period, it's once and for all, and they do not earn any more money from these work periods. And I'll talk more about what happens to fired workers soon. And of course, at the end of the experiment, I do the standard behavioral trait measurements, accepted methods from the field. So here's what the real effort task looked like. They're basically looking at these randomly generated images that have a bunch of shapes in it, and they have to count the number of shapes that have 7 sides. This is taken from Kaplan et al., who want to measure attention costs as they vary the pay in this sort of task. But I make a few modifications for my purposes. First, to make it easier so that I get more granularity in the data on productivity. And second, I prevent guessing by implementing a small time penalty if you give an incorrect answer. Another thing I want to point out here is I include real leisure in the form of this fun fact button that's pointed out to them in the instructions. It says, you know, if it's not worth your time to work the entire work period, you can click this button for a fun little tidbit about astronomy or animals or something like that. Okay, and also I would point out that since this was run entirely online, I can't entirely stop people from using their phone or not paying attention for a few minutes. And the silver lining of that is it'll increase the variation in productivity between workers and between different types of incentives. So once they get to the dismissal threat work periods, instead of being paid per task, it tells them their chance of being fired at the end of the work period. So every task they complete lowers this chance of being fired by a fixed amount until the end of the period when the firing decisions are realized. If they're retained, then they go to the next period and this chance of being fired is reset to the baseline amount. Here's how I include some behavioral components. Apart from using a loss framing throughout the instructions, where I talk about losing your job and missing out on pay, I also include these public announcements of firings, where I display the anonymous worker IDs of people who were fired and people who were retained. You'll notice also that it says, look, these people will continue earning money next period. And basically, if you're fired, you have to sit out. This was shown to people before they even chose which dismissal job they wanted. So they knew this was coming and knew this would be a component of it. Here's what happens to the workers who are fired. You do not get to skip ahead in the experiment. You do not get to earn more money. You basically have to sit here and click this button whenever it appears red. So for 10 minutes, other people are working. You have to remain attentive and click this button when it turns red to avoid losing a tiny bit of money. It's active for 15 seconds, so in practice, hardly anybody missed a button click. The point here is just to control the outside option of workers and reduce variation in it, right? I don't want people getting fired on purpose or completing other leisure or work while they wait for the work periods to finish. Here are the two jobs that I offer them. There are basically three parameters that characterize each of the dismissal work jobs. There's the pay, and then the intercept and slope of the linear firing probability function. So note that in the instructions in software, I always call it just job 1 and job 2 neutrally, but when I'm giving a presentation or in the paper, I'll just refer to them as the safe job and the risky job. So the safe job has lower pay. You earn $2.50 per period, and the risky job has $5 per period. And the intercept varies. So if you do nothing in the safe job, you have a 50-50 shot of keeping your job. In the risky job, if you do nothing, you're fired for sure. And then of course the slope is different between the two jobs. In the safe job, each task you complete gives a 1% reduction in the chance of being fired. In the risky job, it's 2%. Now, when I ask them to tell me which of these two jobs they want, they don't get their job preference for sure. They get it with a 60% chance. And this has a few benefits. It's still incentive compatible, so they should honestly reveal their preference to me. But as the experimenter, I get to observe all sorts of combinations between job preference versus assignment, right? So I get to observe some people who wanted to sacrifice some pay for weaker dismissal threats, and I get to see how hard they work when you throw them into a high-paying, high dismissal threat job. Previous approaches in the literature would do something like work in the safe job and then work in the risky job and then give people a choice. So I collapse this all into one round, which saves time. And more importantly for me, it retains this once and for all aspect where once you're fired, there's no being rehired. You're basically done working for pay for the rest of the experiment. One last thing I want to point out about the design. In the interest of time, I'm not going to sort of show you the model and the calculations, but the marginal benefit of output under the dismissal threat periods in both jobs is always between 1 cent and 20 cents, which are the low and the high piece rate. And this, of course, takes into account the option value of getting to work next period if you keep your job. Okay, which leads me to my results. And my main result is that I find dismissal threats are significantly more motivating than piece rates. Since I just mentioned the marginal benefit of working under dismissal threats is lower than under the high piece rate, it's a strong result or surprising that people work much harder under dismissal threats than they do under the high piece rate. In fact, it's about 23% higher output under dismissal threats than under the high piece rate work period. I'm going to argue that this cannot be explained just by risk aversion, and it cannot be explained by learning. So let me show you what the distributions of output look like. In the high piece rate work period, you see the distribution of output in blue. And under dismissal threats, the first dismissal threat work period, you see it in red. There's just a clear separation in output where people are working much harder under dismissal threats than they do under piece rates, even though there's less money to gain by doing so. If you look on a within subject basis, over 3/4 of subjects produce more under dismissal threats than their own productivity under the high piece rate. And all of these differences are highly statistically significant. Now, you might be saying, this is just risk aversion. Piece rates, of course, are guaranteed income. And when you're working under dismissal threats in my design, you're sort of working for a probability of earning money. So the way I explore this is by conducting some parametric analysis. I use the decisions of subjects in the other parts of the experiment to predict how hard they should have worked under dismissal threats. So I'm going to have to make some assumptions. I assume a quadratic cost of effort function, which is just one of the simplest ways to have increasing and convex costs of effort. And I use constant relative risk averse utility. I calibrate their cost of effort using sort of the difference between their output under the low piece rate versus the high piece rate. And I have their risk aversion parameter based on decisions they made over gambles at the end of the experiment. And when I throw this into the model and predict their output, we get the red line here. So their predicted output Even though risk aversion is increasing how hard they work in the model, it still does not reach the high levels of productivity that I see under dismissal threats. And again, this is a highly statistically significant difference between their predicted output under risk aversion and their observed output. One other thing I'll note here is that I only include risk-averse subjects in this model to give this hypothesis the best chance of succeeding. You also might be wondering whether learning is causing the high levels of productivity because the dismissal periods come after the piece rate periods. Now, I can't really compare productivity between work periods when incentives are changing, but I can look within the same period where incentives are held constant. And whether you look at the dismissal work periods or the piece rate periods, you see the similar graphs here where it looks pretty flat over time. I run hypothesis tests comparing the first half to the second half, and I do not find significant differences in productivity over time within the same work period. So the second result is about kind of decomposing the productivity gains when you intensify existing dismissal threats. So essentially comparing the safe job productivity to the risky job productivity. Now, of course, I find people are much more productive in the risky job. And the interesting thing is that a large component of this is the selection effect. So I'll show you a regression table quickly here. So if we can focus on column 1, the outcome variable is productivity under dismissal threats. So how many tasks did they complete? I just have 2 indicator variables in this model, one for whether you're assigned the risky job, and this represents the incentive effect, and one for preferring the risky job, and that represents the selection effect. Now, in the aggregate results, we see that it's basically all selection effect that's increasing productivity under the risky job. Now, to further explore heterogeneity in the incentive effect, I restrict the regression to only look at people who prefer the safe job and to only look at people who prefer the risky job. And what we see is kind of a backfiring, a negative incentive effect. So people who were willing to sacrifice pay in order to work under weaker dismissal threats, they actually are less productive when you thrust them into the high-paying, risky job. There's some suggestive evidence of a positive incentive effect among the people who wanted the high-paying risky job, but it's not significant at the 5% level. So why would we see a negative incentive effect like this? Well, I would appeal to models of self-selection like the Roy model, where workers select between hunting and fishing, or Borjas's model of self-selection into immigration decisions. People select situations where they expect to perform better. And if you look at the productivity of the people who prefer the safe job, and if you sort of extrapolate, what if they maintained their productivity from the high piece rate into being put into the risky job, most of them would get fired. Okay, so they're put in a situation where they're going to have a very high chance of dismissal. And the takeaway here is that dismissal threats can be demotivating if they're too strong for the ability level of the worker. So starting to wrap up here, what are the implications of my main results? So although most jobs have some implied level of there's a chance you could be fired, in many
Michael, just let
jobs,
you know you're at the minute mark.
okay, thank you. In many jobs, it's not really credible or salient. So workplaces that are focusing on things like commissions or bonuses could get large productivity gains by also including some actually credible and salient dismissal threats. A second lesson is that high-paying, strong dismissal threat jobs are likely to attract significantly more productive employees. So there's a large selection component here. And the third consideration is that if you're thinking about increasing the strength of existing dismissal threats, there's heterogeneity here. It can backfire among workers who did not select this sort of environment and actually reduce their productivity. This is an important consideration when you're considering imposing this on a mixed ability workforce. You're going to create some winners and losers in terms of productivity. For future research, I think it would be really interesting to sort of isolate and turn on and off some of these behavioral mechanisms and figure out what makes dismissal threats so motivating. I'd also be interested in measuring subject perceptions about the monetary benefit of output. Given that piece rates are very straightforward and dismissal threats, it's kind of hard to calculate how much you're earning by working. I'll leave you with this final thought that I think one reason dismissal threats might be so widespread in the labor market could be that this mixture of monetary and behavioral motivators is highly motivating. Okay, thank you.